Hopefully by now you have a better understanding of how DynamoDB works and the different aspect of DynamoDB indexes and primary key. Now we will focus on read-write capacity. This read-write capacity plays a significant role in the price of the DynamoDB. So how much we are going to pay for this particular service would depend largely on read-write capacity in most cases. The other factor which would affect the price obviously would be the storage you consume into DynamoDB table. But DynamoDB table work little differently in terms of performance. Here the performance is allocated in form of read and write capacity unit. So I'll talk about what is this read and write capacity unit is and why I would be interested to know detail about that. Now, in a traditional world, when you have a relational database running, that relational database would be running on a virtual or physical server, whatever the form is. That server would have some CPU and memory associated, and once you run your database engine on top of that and create table, the performance is mostly driven by the server we are using behind the scene. How much CPU it has, how much RAM it has, how much disk space is associated with it. That would control the performance my table at the top can give me. Everything is being boiled down to the physical or virtual infrastructure we provide. Right. If we need to have more performance, we would keep on adding more CPU. If we need more memory, we would keep on adding more memory here directly into the server, and that would be reflecting into a table. Now, on that database engine, if you have multiple tables running or multiple databases, then the performance is allocated to all of them when you are adding capacity in the physical server or virtual server, but you are not able to control in most cases capacity at the table level, performance at the table level, but that is not problematic with DynamoDB as DynamoDB is a managed service. What we can do, we can just host our tables on DynamoDB and all the performance would be configured at the table level. We do not have to worry about the backend CPU and memory. In fact, there is no way to configure CPU or memory for DynamoDB. The only way you configure performance setting is through read capacity unit and write capacity unit. So performance is controlled by RCU, which stand for read capacity unit, and by WCU, which stand for write capacity unit. So what this RCU and WCU is, what is the measurement for these RCU and WCU? Let's talk about that. So one RCU is a one strongly consistent read per second or two eventual consistent read per second for an item up to 4 KB in size. So when DynamoDB is performing a read, you are basically reading a 4 KB size data. It could be if a data is bigger, let's say data is 6 KB, that time we have to perform two read operation for that data. One would be of 4 KB and another would be having 2 KB. So that is two read operations happening there. Right. There is no partial read. So if I'm using this kind of 6 KB items to store and I'm reading that 6 KB item, basically I am consuming 2 RCU here, read capacity unit. Now what is the difference between strongly consistent read and eventual consistent read? You know that difference, we already discussed that, because when we are performing a strong read, what is happening behind the scene that it has to identify a leader and then perform the read operation from that leader. That's what happens when you are using a strong read. When you are using a eventual read, which is your default, that time only operation has to be performed is a read operation. No need to look for leader. So that's why it would be faster. So if I have configured my table for 5 RCU, in that 5 RCU, I would be able to perform 5 strong read, and in that same RCU, I would be able to perform 2 times of 5, which will be 10 eventual read. So whatever RCU configure, you would be able to perform double of that in an eventual read fashion, and the same number would be used for your strong read. That's how this capacity is configured, and I'll show you that into a console in a minute. Once it comes to WCU, which is write capacity unit, a write is considered for 1 write per second for an item up to 1 KB into size. And with write, there is no confusion about strong and eventual. Everything is a strong or a consistent write. So one WCU is made up of 1 KB in size, 1 write per second, and this whole thing is available into DynamoDB console to identify. So I'm going to console, and here we would be creating a table. I don't need to create the whole table, but I'll just give you basic idea that how it would look like. So let's say I'm going and creating all books table, and then I have a key to give. Let's say just call it uh, title of the book, and here is my setting. Now, if I go with default setting, every DynamoDB table by default gets 5 RCU and 5 WCU configured, and obviously it is editable after creation, no problem at all on that. So I would go ahead and modify that to a different setting. For that, I would select a customized setting. So when I'm selecting customized, I have option to select the table class. This has majority of pricing information detail. Like if I'm selecting DynamoDB standard, this is mostly a general purpose table which I am using data on a very regular basis, and that is where I would be paying for store frequently accessed data and throughput, which is read and write, as the dominant table cost. But in case you have some data which you do not access frequently, you may want to keep it into DynamoDB standard infrequent access tier, where the cost is more dominant by the storage you use, and this was relatively is a new feature. Right now I am interested into a capacity calculator here, and here I could perform some verification of how much capacity I should configure depending on the size of the data and how many reads I want to perform, how many of them eventual, how many of them strong. So let's say my requirement is I have an application which requires 4 KB of item to read, and we plan to read up to 10 items per second, and I want that to have a strongly consistent read. So that is reflecting here. I would be needing 10 read capacity unit for 10 items of 4 KB in size. If I say 5 KB in size, that would double my read capacity unit if I have to still perform 10 read per second, because now I am consuming 2 read capacity unit for every item. One capacity unit will read 4 KB data and remaining 1 KB. And if I say, okay, let me clear it, make it simpler again, 4. And now I say I don't want strong consistency, but I want eventual consistency. So same 10 read per second for a 4 KB item would be delivered to me into a 5 RCU configuration only. So I'm just providing the half RCU configuration, and I would still be able to perform 10 read per second, but in an eventual format. Right, so hopefully this thing is clear. And it also tells me the estimated cost based on what I configured in this case. Then we have other option here called transactional. So transactions are supported by DynamoDB, where you could have a whole transaction like a money transfer happening from one account to another account, or a sale or purchase happening for a specific product. So those transactions are also supported by DynamoDB. Right now, I am interested also to know the write capacity. Let's say my item is also, when I write, it is going to be 1 KB only, and I want to, sorry, item size is 4 KB, but I want to perform, let's say, 10 write. So if I'm performing 10 write, in a standard fashion, I would be needing 40 write capacity unit. That is 4 into 10. That is the number coming up. If my item was just 1 KB in size, I would be needing 10 capacity unit, and this would be my cost associated. So this is my capacity calculator, very handy tool to estimate the prices. The actual charges may still be varying, but this is giving you a good idea of how much you may end up paying when you start using DynamoDB tables. Right. Below that, we have option to select capacity mode or capacity setting. There are two settings available. One is called on demand and another one is called provision. I'll talk about that, but let me first go to the slide and give you some detail, and then we will discuss about how these modes would be affecting you. So I'm talking about DynamoDB capacity mode. We have two capacity mode, read, write capacity mode. What are they? Let me explain that. You may have a provision mode or you could have a on demand mode. Provision is I set a value. I say, hey DynamoDB table, give me 10 or let's say 40 RCU every time that I provisioned for. I have already asked, in a way you could think of like it's a upfront kind of reservation. We have asked DynamoDB to keep for us. So that is called my provision mode. And then second mode we have here is a on demand mode. Whatever request comes in, DynamoDB would be able to handle that without you worrying about capacity planning. In provision mode, obviously I have to decide on what capacity I plan to use, and based on that I would be configuring provision mode values. But in on-demand mode, I have nothing to worry about. Just select on demand and DynamoDB would take care of scaling up and down depending on the request which is coming up. But is both of them have their own challenges, plus and minuses, so we have to be very careful in what we select. But the good part is this can be changed over the time if you need to. Maybe you initially started with on demand or provision and then you want to change it later. No problem at all on that, and you can configure that change to happen also in an automated fashion, because at the end everything is an API call in AWS. Right. So what these modes are? Provision mode says we will provision the capacity to run at a specific limit. We would set up what we are looking for, and that would be provisioned for us, that would be kept ready for us. That is my provision mode. Second one here is on demand, which says no limit scaling, serving thousands of requests per second without capacity planning. So that is my on demand mode, and if you see this graph, I have put that as a straight line, and this one is a zigzag pattern which may change over a period of time. Charges, how you pay. In a provision mode, you pay for what you configured into your application. What I mean by that, so if you have said that, hey, I want to have a specific number of RC or WCU always available, you would be paying for that. So here you pay for provision capacity whether you use it or not. Think like you booked a hotel room which is non-cancelable. You booked it, whether you stayed or not, you have to pay. You booked 10 room, you stayed in only on 2 rooms, or your guest arrived only for 2 rooms, 8 are still there, but you are still paying for it. That is your provision mode. So you pay for provision capacity whether you use it or not. So be aware about what you would pay. Then you may be thinking, then why somebody would use it? Idea is that this is giving you a peace of mind, that this is giving you a specific amount to pay every month. You are not surprised by change into the cost of DynamoDB table. So maybe your application or a budget for DynamoDB table is, let's say, amount X. If you are using provision, it will not go beyond that X amount, whatever you want to achieve. So that's why it is giving me little peace of mind in terms of how much I may end up paying for DynamoDB. Whereas in on-demand mode, what happens, I am paying for read and write we perform. So yes, if we perform one read, we will pay only for that. Right, give me a minute. One read, we will pay only for that. And if we perform 10,000 read, we would be paying for that too. So yes, your bill would be always variable, but in case of provision, it is always going to be a almost fixed amount. So on demand may work well, but what if you were expecting 100 requests to come in? Maybe due to some fault or error, or maybe due to some of the misconfiguration, or maybe some hacking, you have lot of requests coming to your table. And now you are liable to pay for that because you configured it to be an on-demand mode. So that is what you have to be aware. Maybe you should put some alerts into picture. You should set up some type of mechanism to identify if that billing goes beyond a specific threshold. Maybe I want to get notified about it. So that can be done. The benefit of provision mode is that you can control the cost, as I said, and if you know what you are looking for, you can ask for DynamoDB capacity reservation. Same like you do EC2 reservation, you could also do capacity reservation for DynamoDB table, and that would obviously will be giving you better pricing in terms of your monthly billing. So that is your provision mode. On the on-demand mode, the benefit is you can instantly accommodate your workload as the traffic ramps up or down. You don't have to worry. You just say I want to have a on-demand mode and everything will be taken care by system. Now, if you are thinking like if I configured, let's say, provision mode for 50 RCU or whatever, and what if the request keeps on coming and they request 60 RCU? What happens in this case? In this case, DynamoDB would go through throttling. So throttling is happening because we do not have sufficient capacity planned and there are more requests coming in. Like if you have a specific place where number of people can only enter, and if the people waiting are more, then obviously there will be throttling. They have to wait till that the space is available and they can come in, and you may have to implement that retry type of logic in your own application. So throttling may happen in provision mode if your requests are going beyond what you configured for your application, right? So let me go to console and let's see this information into action. So if I say, hey, I want to go with on demand, I don't have to worry at all. Simplify billing by paying for actual read and write your application perform. That is my on demand mode. Now, when this on demand would be better and when this provision mode would be better, let's see that. So provision is suitable if you have a steady state and a predictable traffic, right? If you know what your traffic pattern is, maybe every morning you have less requirement, every afternoon you have high requirement, evening again less requirement. So there is a pattern there. There is a steady state of the traffic which you are expecting on a day-to-day basis. That time provision mode can be a better choice for you. On-demand mode, on the other hand, is good when you have a random and unpredictable traffic, right? So on demand, let's say I have launched a marketing campaign and I'm not sure how many of the users would be using my application. I need to be ready for whatever surge or spike I get. On demand is better. But if I know and I want to be budgeted for the price I am paying, I would probably go ahead with my steady state. So if I'm, let's say, running a QA environment on a continuous basis, and then I may put a provision mode on that, even if tens and thousands of tests run on that particular table, I won't be paying beyond a specific number. Let it throttle. Maybe that is not a critical workload for my application. So that's why you have to decide on what will work best for you. When I configure provision mode, then I have to specify some more setting, which is called your floor and ceiling setting. Here in this case, we configure with provision mode, which is manage and optimize your cost by allocating read write. In provision, we have a feature which is called auto scaling. I could say, no, I don't want to do auto scaling at all. So see what I did here. I said provision plus auto scaling off. That means I would pay for 5 read and 5 write come what may, and I'm not going to change my scale, change my read write capacity based on whatever request comes in. So that is no auto scaling, just a flat 5 RCU, 5 WCU configured. But with provision, you can again give a minimum value and a maximum value you are planning for. So I could say, hey, I want to use provision. I know what is my minimum and maximum value, and let me dwell between them. Let me shift from one minimum to another maximum, and then, sorry, minimum to maximum, and adjust my capacity based on that, but keep some buffer available for me. Right. So that time I could go ahead and configure auto scaling, and in auto scaling I could say minimum capacity I want to have, let's say, is 1, maximum I want to use 10, and target I am planning is 70. So DynamoDB would always keep 30% room for growth, not beyond 10, not below 1. So that is my target utilization, which I could configure, and that can be done for both read and write. You specify minimum value, you specify maximum value, and you put a target utilization you most of the time expect to use. Right, and that 30% is a ceiling available, and DynamoDB would adjust that till it reaches to maximum capacity unit. So it's a kind of a best for way when you have a pattern, or let's say sometime your traffic is low and on regular time it spikes and then comes back. So it would keep on adding capacity up to it reaches to maximum on its own. right? But you are still within the maximum limit, so you won't get any surprises in your pricing or in your monthly bill. So I could configure these settings also, should not be problem. Here it is called minimum capacity and maximum capacity. I plan to call these as steady state, and I call it a floor and ceiling. So I could configure a floor and a ceiling. It can be set up using auto scaling in provision mode. On demand, you can scale to zero, no ceiling, whatever request comes in, we should be able to fulfill by the backend services DynamoDB provide. So that's how easy it is. And you can change this setting even after table creation. So maybe when you do not know what type of your workload access pattern is, you are just starting a new application, maybe better to start with on demand. And once you have a fair idea of what actual utilization may look like, may go for provision mode, because provision mode will also help you to do capacity reservation, which will eventually save some dollars for you. So that would be a better approach if you want to. So decide what works well for you. Maybe it would require little type of back and forth before you actually decide on what you want. And maybe you started the provisioned, kept it like that, launching a new marketing campaign, unpredictable traffic pattern coming up, go to on demand should not be a problem. So I hope you have a better understanding on the DynamoDB capacity mode. Expect some question on these, that what time on demand would be better and what time your provision mode would be better. So I would say this line is important. So if you have steady state and predictable traffic, go for provision. If you have random and unpredictable traffic, go for on demand mode. So I hope you are learning something new, and I'll talk to you into the next section. Thank you.